please check out your answers to A, B, and C. And if you got anything wrong, then stay with me and I'll explain this a little bit. If you got them all three correct, then stop the video and move on. So the two things we're looking at here are factoring the difference of two perfect squares and then also just factoring a trinomial. Okay, so with the difference of two perfect squares, we end up getting this, of course, and then whatever the square root is, because there's no middle term, right? That means that these signs have to be opposite. If you don't believe me, then multiply these back, and you'll see that we get to the x squared minus 16 because the inside and outside zero out. Notice how if I have the exact same binomial, but the signs are opposite, that's what causes the middle term to zero out. That's actually going to be important to us later in the lesson. Okay, and something like this, again, this is a perfect square because this would be 2 squared, right? And this would be 7 squared. Okay, so then it also factors into same idea here. It doesn't matter if I put the plus or the minus first. You probably are comfortable with that notion. Okay, and then I am going to assume that people have a reasonable handle on factoring something like this where the a term is 1. So remember how we write our quadratics, ax squared plus bx plus c. Okay, so if I say a equals 1, I'm referring to the leading coefficient. A lot of you would say there is no coefficient, but the coefficient would be 1. So anytime that a is 1, and I'm going to erase it because we don't write it there. Anytime the a is 1, all you have to do then is look at that last number, that last term. All right, we get negative 18, and then you're looking for factors of negative 18 that add up to negative 7. So I always suggest students list them, and to multiply and get a negative, one's positive and one's negative, right? So we always have 1 in itself. If we go in order, we won't miss any. So 2 and 9, 3 and 6, 4 doesn't go in, 5 doesn't go in, 6 goes in, but I already have it. As soon as I repeat, I'm done. All right, so that's the advantage of listing them out in order. And I'm trying to make negative 7, so I have to select these, and that would make the negative on the 9 and the positive on the 2. All right, and so this would factor into x plus 2, x minus 9. So you might be comfortable with the 3 examples I just went over, but you might have still had trouble back on the exercises, right, back over here. Because the very first thing you should look at when you're factoring, and this happens in both A and C, is you should look and see, is there a greatest common factor that I can factor out first? Okay, and in both of these, I could take out an x. I can take an x out here and an x out here. Now, when I take an x out here, then what I'm left with is just a basic quadratic. Right, just like we worked on that last page, right? So I would list factors of negative 12. So one's got to be positive, one's got to be negative. 1 and 12 are definitely not going to work. 2 and 6, no way to get 1 out of that. 3 and 4, I know I've got all the factors of 12 because I repeat, right? 3 goes in, 4 goes in, but I already have it. There, it's got to be my negative. This has got to be my positive. When I factor out an x, sometimes students think it just like goes away, right? Make sure you put the x here at the beginning, because what I have to be able to do, remember, distributing and factoring are inverses. They undo each other. So I need to be able to multiply this back and get back to where I started, right? So if I multiplied it back, wouldn't matter the order I went in. I can distribute the x first to here and then FOIL, or I could multiply these, FOIL first and then distribute the x, and it doesn't matter. Okay, but that's how I double check my work. Now over here in B, that's a difference of two perfect squares. Probably if you missed it, it's because you wrote it like this, right? But the difference between, like, the term on the right, these are equivalent, right? Because 3 plus x, x plus 3, those are equivalent. This would differ by -1, right? 3 minus x, the difference between that versus x minus 3 is -1. So you'd be off by a factor of -1. And if you don't believe me, compare something like this, right? What's the difference between these answers, right? 7 minus 3, that's 4. Well, what's 3 minus 7? That's -4. So sometimes students approach this this way, where they actually factor out a -1. So if you wrote this, right, this is equivalent to what I have up here. So actually, if you did have that on your paper, you are in fact correct. Now, back to letter A, I can factor out an x. I can also factor out a 3, right? So when I take out that 3x, that leaves me with x squared minus 25, and you need to be able to recognize when you have that difference of perfect squares. So back in the lesson on square roots and radicals, I had you make that list of perfect squares, and so you should get yourself familiar with, recognizing that anytime you see 4, 9, 16, 25, 36, 64, dot, 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 on and on, you have perfect squares.